Assalamualaikum and hello to all. We are going to proceed to chapter 9, which is reaction kinetics. Okay, factors that affect the reaction rate is concentration or pressure, temperature, particle size, and catalyst. We are going to cover all this. So what is the factor that affecting the rate of reaction? Concentration or pressure, what happened? When concentration or pressure increase, the number of particles per unit volume increase. Okay, let me draw example. Okay, I need to change this one first. Enter option in color yellow. Okay, let's consider we have uh, 5 molar of a solution here in closed vessel. So you can see there is only a little amount of it. But when we have for the same volume, let's say we have the same volume, but now we have 50 molar. So you can see there will be a lot of the particle per unit volume because this is 50 molar. So what happened is number of collision increase. Okay, collision increase, the collision increase between the molecule will increase. So you have higher number, of course there will be a lot more collision that can occur. Okay, what happen when number of frequency of collision increase? Okay, the number of effective collision increase. If this molecule collide slowly, nothing will happen. Okay, but when it collide effectively, okay, we can say the reaction can occur, and this will increase the reaction rate. Okay, so concentration or pressure will increase the rise of concentration of reactant or pressure. It will give the effect of reaction rate, which will increase. Okay, what about temperature? When temperature increase, average kinetic energy of molecule increase. Okay, I draw a particle. Let's say this is a particle. This is another particle. And this is another particle. When you give uh, energy, let's say fire. This is fire. So this thing will move uh, much more stronger, much speed. Okay, average kinetic energy is increased, so it might collide with each other. So the number of molecule with high energy or equal or larger than activation energy. Okay, activation energy is the energy that needed for it to have effective collision. So if you have one more here, they will move around with higher energy, so effective collision increases. When effective collision increases, what happens? Reaction rate also increase. This also works in reverse. If you lower the temperature, we can say reaction rate will be lowered. Why? Because there will be lower number of molecule with energy equal or larger than activation energy. So number of effective collision decreases. Reaction rate decreases. Okay, if you lower the temperature, if you increase the temperature, this will happen. Okay, next one, particle size. When particle size decrease, the surface area exposed will increase. Okay, let me show you example. Let's say we have a cube of sugar. A cube of sugar. Okay, a cube of sugar. When you break this up, okay, you break this up, it will become in smaller chunks. Okay, when it is smaller, it means you have higher surface area. Okay, higher surface area. Okay, you have higher surface area. Okay, I hope I draw it correctly. Okay, okay, so small particle, it means that you have high surface area. Compared to this one is large particle, so it will have a lower surface area. Okay, so what happens when you have higher surface area exposed? Again, the number of frequency of collision increases. Okay, so this can collide each other, can collide each other, can collide each other, can collide each other much more frequently. So what happens is effective collision also increase. Okay, how can we get effective collision? It must collide with equal or higher energy than EA. Okay, EA is the activation energy. So reaction rate will increase. Okay, next one is catalyst. Catalyst is something that can speed up a reaction. So the first sentence here tells you that catalyst can alter or changes the rate of reaction by providing alternative pathway with a lower activation energy. Okay, what does this mean? Okay, if we draw energy profile diagram here, okay, if I draw energy profile diagram here, okay, let's say this reaction, this is reactant, and this is product. This is exothermic reaction, mean energy is released. Okay, the area here, not the area, the line here is actually what we call activation energy. Activation energy. In short form, it is called EA. E is energy, A is activation. So activation energy. So by having catalyst, so this is the area of activation energy without catalyst. So when you have catalyst, it actually the lowers the activation energy. So this is the new. So this is the new activation energy. Okay, so this is with catalyst. Okay, EA with catalyst. EA with catalyst lower. So if we imagine there is someone who wants to climb up this hill, it will take lower energy to climb the one with the lower hill. Okay, so that's what it means. This one does not change the enthalpy. Enthalpy is the energy lah of the reactant. When catalyst is added to the reaction, okay, more particles have higher energy than EA. Okay, because the energy activation energy is now lower, right? So when it is lower, means more particles have higher energy than EA. So number of frequency of collision also increases, and what happens next? Effective collision increase. Okay, effective collision increase. So what happened finally? So reaction rate will also increase. Okay, so can you review all the factors that can affect reaction rate? Okay, so the first one is concentration or pressure. The second one, particle size. The third one, it can be temperature, and this one it can be catalyst. Okay. Okay, so that's it. So good luck. Bye.